All right. Let's try this. Hold on. Let's come on. At least pretend that we're all normal here. Are you ready? Okay. Class.
Yes.
All right. Good. All right. Find calculator approximation for each circular function. So, what do you think this actually means?
Put in the calculator.
Put it in the calculator.
Do you want it in rad or do you want it in degrees?
Okay. What mode have we been dealing with so far this entire section?
Rad.
Thank you.
I just want to make sure.
So all these are going to be in rad because we've been dealing with just rad.
Yeah, I got that.
But once we get to the next part, it's going to be slightly different because your calculator does more than what these calculators have. Because back when these slides were made, everyone was still using the 84s. I know, right? Ugh.
When did this calculator come out? Like what year?
12?
Oh, so that's like pretty recent.
Actually, no. The first gen was 12. This is second gen. No. Second gen is 12. First gen was like 06, 05 or something like that.
No, this is insane. Let's keep going.
All right, so just plug it in the calculator, you get the same numbers, right?
Yeah.
Okay, so for C and D, they're going to be slightly different. So it says cotangent of that number. Now, for you, since you have the amazing calculator, so change my mode. And the first one's cotangent, right? Hit the trig button. And cotangent's already here. And then my number that I'm plugging in, what was the number they used? 1.32.
Oh, you saying 85?
Like that?
Yeah. Oh, no.
Okay. All right. Hey, look. Our calculators actually have a cotangent button, so it makes life even easier. There we go.
But they gotta go through some extra stuff on their calculator.
Yes, they do. Because they have to put 1 over because cotangent is the reciprocal of tangent. So you had to put it in upside down. Secant, negative 2.9234. 2 point what?
9, 2, 3.
Like that? There we go. So if you're on one of those other calculators like your 84s, these notes, so if you're at home and you're having trouble with this, but you have access to Wabbit Emu, the app that actually has a TI-84 calculator on there. Yes, that one right there. So that's how you would do these, step by step. That's the reason why I keep these in your notes. Because in class I show you how to use the Inspire, but if you're at home looking at the notes, yeah, it still shows you how to do it. Caution, make sure it's in radian. Approximate in a value of S in the interval. Now, S is just going to be the variable that we're using. Don't freak out and think it's S like the pizza crust that we had. So it's just the variable of the angle. And the angle is within this quadrant. What quadrant is between 0 and pi over 2?
Quadrant 1.
Yeah, it is quadrant 1. So my answer is going to be in quadrant 1. My answer is in radian, isn't it?
Yeah.
It's in radian, it's in quadrant 1. Good, right? That's important to understand. I circled that because once we get to the text coming up here soon, you're going to have some other problems. And you're going to have, instead of saying 0 to 2 pi, it would say 0 to 90. What would a 0 to 90 tell you for your mode?
Degree.
It would be degrees, right? 0 to 90 degrees is quadrant 1. But 0 to pi over 2 is also quadrant 1, but that's radian. So that's important when you're actually looking at this. So now, if you're looking for the angle, you do the
inverse, yeah.
Inverse.
They
Who was that person that messed everyone up? That they keep saying opposite.
That was
you.
no,
That was you.
It was not me.
It was, right? How dare you? All right, inverse. Say inverse.
Inverse.
Okay, if you're looking for the angle, you do the
Inverse.
If you're looking for the angle, you do the
Inverse.
Thank you. So if we keep saying it over and over again, it pops back up in your brain. So let's do the inverse. So it's going to be S equals inverse cosine there we go. And just plug that into your handy dandy calculator. So when you hit that trig button, you also have that right there too. All right, and since it's in radian, help me out. So S is going to be about
You got that thing? Huh? You got that? 0.25.
like that. Yee. Very good. Any questions? Any concerns? Any complaints? No. Find the exact value of S in the interval of pi to 3 pi over 2. What quadrant am I looking at if I start at pi and go all the way to 3 pi over 2? What quadrant? Quadrant 3. Very good. That is quadrant 3. So it's going to be quadrant 3. That's important. If tan S is going to be 1, so this is an exact value problem. So I'm going to use my unit circle here. So on my unit circle, you have to think about this, because exact values means that I'm going to have something within there on my unit circle. So it's going to be S equals inverse tangent of 1. All right. So looking at tangent. Tangent is y divided by x. Tangent is y divided by x. To get 1, if I had y divided by x, what had to happen that my x and my y, or my x and my y are? They're both what?
1.
They're both 1.
They could both be like the same thing.
Both same things. So let's go ahead and take a look at quadrant 3. Look at quadrant 3 now. So in my unit circle, in quadrant 3, I'm looking for somewhere that the x and the y are the same.
Oh, is it 5 pi over 4? I think. No, the x and the y, right? Meaning like
X and the y, because
yeah, 'cause
if
they're
you
both-
think about it, it's y divided by x. To get 1, they both have to be the same, don't they?
Yeah, they're both negative rad 2 over 2.
Very good. They're both negative rad 2 over 2. So that means that S exactly is going to be 5 pi over 4. So if it says exact value, that means that you're going to find this answer on your unit circle.
Because there's only one of them on there, right?
Yeah. Does that make sense now or no?
Yeah.
Anyone questions?
Are there any other intervals on here that would be like that? Or like where like x and y, oh yeah, you have pi
Yeah.
over 4 is like that, and then
You mean quadrant 1?
Not quadrant 1.
Quadrant 1's like that. What happens in quadrant 4?
Quadrant 4?
What would your tangent down there be on quadrant 4? That would be a -1, wouldn't it? Because you have a positive and negative in quadrant 4, so that would be a -1, isn't it?
That was going to be 7 pi over 4.
Yeah, very good. And what about in quadrant 2? What would it be in quadrant 2?
Is it also going to be -1?
Yes, it is.
And that one's 3 pi over 4?
Yes, it is. Very good.
So like each one of the quadrants has one like that?
Yeah. So, let's see. Let's keep going.
Oh, is it? Okay. No, I get it.
All right. See all this hot mess right here?
Yeah.
This is ugly, isn't it? Just plug it in. You're just going to plug in the values. Because you're going to have angle of elevation theta, latitude L with different formulas. All this other stuff. So here's the formula you're going to use. So, where's that? Okay. So there is a W problem. So there's W. There's D. There is latitude, or we're going to use radian. We're finding the angle of elevation. So you have a problem like this, just plug it into the calculator. Just plug it into the calculator. Just plug it into the calculator. There's no reason to do and try to make this one complicated. They'll give you like 3 numbers. You just plug it into the calculator. They give you a formula, just plug it in. And since it comes out with sine theta, we're looking for theta. So my last thing I do is the inverse. I would do the inverse when I was done. Well, other than that, listen, this problem's a hot mess. I hate doing this problem. I really do.
It sucks.
It's stupid.
Can you show me what I'm supposed to plug in here? Oh, it's on the other page.
Yeah, it's right there. That's all you got to do. So if you go and look at the homework, I'll show you here in a moment. That specific problem, it gives you a formula. All you have to do is plug in the values that they give you. Okay? All right. So from there, make sure you guys all... Wait, hold on. Links, line segments. Sine, cosine. What the hell's all this? We already know all this. We know all this. What the hell's this? Where'd these notes come from? I don't even remember doing this.
They're on the paper.
Oh, are they on the paper too?
Yeah.
Yeah.
What is this?
What the deuce?
Unit 5 or something.
I remember I went into that thing that worked, and then I looked at the wall and it said drop it.
Oh, okay, no, yeah, that's actually not in the homework.
That's not a no mark?
No,
No point then.
no. And so maybe that's why I'm like losing my mind. All right, so make sure you guys all like, share, and subscribe. Hit that notification button and support my channel. Like I said, I'm dropping new socks this week on my merch store. So